Hello students, today we are going to discuss a very important topic, that is the electric generator. See the parts of the electric generator. It has a strong magnetic field, NS, north south poles, and between these poles we have armature, that is a coil, metallic coil of the coils, and ABCD shows the armature. Okay, it is known as the armature. This coil is known as the armature. It is connected to the two slip rings R1 and R2, and these rings are in contact with the brushes B1 and B2. We are taking the output here in the bulb. Okay, now see what is the principle of this electric generator. We know very well in the electromagnetic induction, when a coil is placed, when a coil or a conductor is placed between the poles of a magnet, that is in the magnetic field, then induced current is produced. So you can say its principle is it is based on electromagnetic induction. Okay, this is the principle of the electric generator. Now see its working, how it works and how it is different from the electric motor. See the electric generator, it is a coil, okay, ABCD. Now to find the direction of the induced current, because when it will rotate in the magnetic field, the coil will rotate in the magnetic field, induced EMF will be produced. So what will be the direction of the current? It is the more important. So you can find the direction of the current using the Fleming's right hand rule. Okay, Fleming's right hand rule. Okay, if we use the Fleming's right hand rule, I can show you. You know the magnetic direction of the magnetic field is from N to S. This is the direction of the N to S. This is the direction of B. Okay, and the direction of the motion. Suppose we are assuming that AB is in motion in upward direction. Suppose it is in upward direction. Then what will be the direction of the current, induced current in this coil? If you see the right hand, Fleming's right hand rule, you can see the thumb will show the motion, and this finger shows the direction of the magnetic field, and this finger shows the direction of the induced current. Okay, now keep this finger in the direction of the magnetic field. Okay, this is N to S, and suppose the AB is moving in upward direction. Okay, AB is moving in upward direction. So direction of the current, this is the direction of current. Okay, this is the direction of current. This is the direction of current in AB. That is the A to B. Okay, in the same way, if you see CD in the second arm, direction of the magnetic field, this is the direction of magnetic field. Okay, and at the same time, when the AB is moving in upward direction, CD will move downward direction. So direction, it is in downward direction. Okay, thumb will show the motion of the conductor. So it is this, and the direction of the this is the direction of magnetic field, and thumb will show the direction of the motion of the conductor. So what will be the direction of the current? It is from C to D. Okay, it is from C to D. This is the way to find the direction. This is the induced EMF. It will show the direction of motion, and induced current will be produced. I think it is clear to you. So this is the way. Now it means the current will move like this. Okay, this is the direction. Okay, it will make the closed loop. This is the direction of current. Now what will happen after the half cycle? Just I'm showing, this is the armature. So after half cycle, what will happen? It's CD, because this is the direction of A to B, and here the direction is from C to D. So when it moves, then what will happen? CD will take the place of the AB, like this. Okay, AB was here, initially it was here. So now CD will take its place. And initially the direction of the current was here, positive direction, A to B. I'm showing the direction again, A to B, and it was C to D. Now after half cycle, what will happen? C to D, this is the direction of current, and this is the direction of current in AB. So after half cycle, the direction of the current will change. After half cycle. So after every half cycle, the direction of the induced current will change. It will reverse. And these brushes will change its position. Okay, so B2 will be in contact with R1, and R2 will be in contact with B1. Okay, position of the brushes will change, because only this green color, it will move, not the brushes. Okay, brushes will, these B1 and B2 will be stationary. Only this armature with the rings R1, R2. Okay, so here R1 and R2 are the slip rings. These are the slip rings. Okay, so after half cycle, the direction of the current will change. Okay, like this. Suppose in half cycle it is positive, in next half cycle it will be negative. So like this. So we get AC current. AC, that is the alternating current. The current which changes its direction after every half cycle is known as the AC current, alternating current. That is, it is always bidirectional current. So this is the working of the electric generator, AC generator. Now to get the output as a DC current, what we will do here? If we replace R1 and R2, that is the slip rings, by the split rings, as we have used in case of the electric motor. Okay, split rings, these were the split rings. Okay, a ring is cut between half both sides. Okay, this is the split rings. So it was the commutator. So if we replace the slip rings by the commutator split rings, then it will work as a electric motor. This, because DC gives this in DC electric motor we use the DC, and here we get the output as a DC if we use the commutator split rings in place of the slip rings. Okay, so this is working about the DC generator. Okay, so this description is about the AC. Okay, to change it DC, what will do? You will change slip rings by the split rings, as we have used already in case of the electric motor. Okay, now AC, its frequency is 50 Hertz. The output, its frequency is 50 Hertz. That is, after every 1/100 seconds, it changes its direction. Okay, changes direction always. Okay, remember in AC. And one more advantage, the most important advantage that the AC over the DC is that electric power can be transmitted over a long distance without much loss of the energy. So in our power generation centers, thermal power stations, different power stations, only the AC is produced, which can be transmitted to a very long distance. So this was about the electric generator. Thank you, students.